some good examples here. People are coming up with exactly what I wanted, which is drawing without replacement from typically a cookie jar, which is good. We've got people talking about different types of screwdrivers, different genders of fish, different types of kiwi birds, cookies again, poker, pens in your bag, and you've got red pens and blue pens, and you pull out 3. Screwdrivers, cookies, fish, male and female. That's a nice one. You've got 7 people. 3 male and 4 female. And you want to choose 3 to go on a trip. This is an excellent example because it's pulled it quite far away from pulling balls out of a bag. Most people's examples have actually got an actual bag, which is kind of fair enough, I suppose. But you can't put these people in a bag. I like this way of thinking. What's missing from all your examples, because I've not taught it yet, is why on earth you'd be interested in any of this. Why would you be interested in choosing 3 to go on a trip and want the probability that all 3 are female? Why would you care? Maybe
shore up the different type of supplies you'd need.
Indeed, yes. Or maybe if it's 3 girls together, maybe they'll be really badly behaved.
Compatibility.
Who knows?
Compatibility.
Compatibility, indeed, yeah.
Oh yeah, or peace. You know, if there's 2 women and 1 guy, there might be competition for the guy. If there's 2 guys and 1 woman, there might be competition for the woman. If there's 3 women, then...
Sweet, that'll do. I'm going to change this example. Actually, I'm not. I'm going to leave it like this. I'm going to keep the 7 people, but what I'm going to choose, instead of 3 going on a trip, I'll say 3 get promoted in the workplace. Now it's a little bit more interesting. Did this occur by chance? Which is the promotions made no reference to gender. Well, of course. If you've got 7 people in your workplace and you promote 3 people and it just happens that all the girls got promoted and all the boys didn't get promoted, that looks like evidence of sexism. It's one of the reasons I moved from my first job.
Sexism?
Indeed, indeed it was. Because I did this test. You asked me earlier, do I get excited about Bayes' theorem? And yes, because I said, well look, there's these criteria and that's many boys and that many girls, and it looked to me like all the female staff were getting promoted and the males were being looked over. It's the kind of thing that's very amenable to statistical analysis.
And the other one is also teachers being promoted to DP roles out of a group of 5 of them.
Yeah, it's any kind of thing that you...
So this is what you would bring with you to court if you were going to try to sue for your job.
Yeah, although I took the easy way out and came here. Hey ho. Okay, so let's just think about what tools have we, what inferential tools have we got here? Well, we can take a null hypothesis. This is a null. The null is that the promotions were made independently of the gender. So whatever process governs or drives the promotion process, you don't care whether they're male or female. And the alternative is, of course, that the female people were given some kind of preference. But what distribution do we need to see about the null hypothesis? What distribution? Oh, sorry. What distribution do we need to investigate what the null is? No, not binomial. Hypergeometric.
Hypergeometric.
Because you've got a bag of people.
Yeah.
You've got a bag of people. Once he's been promoted or she's been promoted, they're not getting promoted again.
Right.
All right. So there's a nice way of drawing this diagram, which is this. Promoted and not promoted. Okay, so we know the marginal totals. We know we've got 3 male and 4 female employees. And all the females, no, is that right? 3 male and 4 female.
3 male, 4 female.
And 3 get promoted and they were all female. So the promotions split 3 and 1 because it says it here. Choose 3 to go on a trip, 3 to get promoted. See how I'm sort of slipping between the interpretations of white balls and black balls and left in the bag and drawn in the bag. How many got promoted? 3 got promoted. 0. There you go. That's nice. Promoted and not promoted. I'll come across simple examples or lots of examples of this form of reasoning. I would say that about 1/3 of my statistical consultancy is drawing up data in terms of a table like this, whether it's screwdrivers or promotions or kiwi birds or cookies or carrots or whatever it is. Whether it's trips to the doctor, whether it's mortgages, whatever it is. You can draw up lots and lots and lots of data like this, and I want you to be thinking about how your portfolio data sets can be drawn up like this, okay? So let's just have a look at this. What is the probability of that occurring? So, which one shall we do? We'll do it with this. We'll do it with this this formalism here. We could do it the Wikipedia way, or we could do it the R way. We may as well do it the R way. Okay. So first of all, we decide that white equals promoted. Black, no promotion.
So we're turning everybody into balls now.
Yeah. Actually, no. This doesn't. That doesn't. Well, it does work. I'll show you later that it does work, but it's easy to do it like this. Black and white correspond to male and female. How many males have we got? 3 and 4, right? So promoted. Oh God, what am I doing here? Maybe I've swapped it around again.
It's probably, okay, you got...
Yeah, I'm gonna draw 3 people out to get promoted, and I'll see if they're black or white for male or female.
Yeah.
So I was right the first time. Yeah? Let's try that again. What I'm going to do is I've got 7 balls in the bag, of which 3 are male and 4 are female, and I'm going to draw them out of the bag. I'm going to draw 3 people to be promoted, and they sit in a nice office. I'm going to draw them out, and they can sit in their office with a nice pay rise, yeah?
But your question was, 3 get, choose 3 on trip?
Yeah.
Probability that all 3 are female.
That's right.
What's the probability that all 3 are female?
So I'm going to choose 3 to go on a trip because they've been promoted. It's easy to get confused here. Mathematics, one of the reasons I'm getting confused is that it's the same. So black equals, which way around should we do it? That equals male. White equals female. We draw 3 to be promoted. And observe that all 3 are female. It's worth spending a bit of time getting confused about this. I want you to see how confused I got by it.
Right.
Yeah? After a while, you ignore the drawing out and you just do the 2x2 contingency table here. And I'll show you some examples where the concept of drawing doesn't really make any sense. Okay? What's the probability of this occurring? Right. We've got M, we've got N, we've got K, and we've got X. M is the number of white balls, which is 3. N is the number of black balls, which is the number of males, which is...
White is 3.
No, white is 4, isn't it?
Yeah.
3.
Is that an N or an R?
That's an N.
Yeah.
Lowercase k is the number of balls drawn from the urn, which is the number of promotions, which is 3. And X is the number of white balls drawn, which is all 3, yeah? Okay, so all I'm doing is translating my male and female, promoted and not promoted, into black and white, drawn or left in the bag. Because you get drawn for promotion, yeah? And then you go on your nice holiday because you get paid a nice pay rise. And it's males.
Number of promotions.
M was 4. N was 3. And K was 3 as well. So if the null hypothesis is true, remember the null hypothesis is a sort of inversion of what we have here, which is what we suspect sexism. The null hypothesis is it's all random. How often does this pattern occur by chance?
11%.
11% of the time.
Pretty slim.
So the P, well, it's above 5%. You see, we can use the other half of this course, we can use p-value, which is the probability, if the null is true, of observing the data, or one more extreme. And if you're suspecting sexism, you can't get more extreme than this, because none of the men got promoted, and as many of the women got promoted as they possibly could be, given 3. So that's a p-value. It's worth writing out the definition of p-value again and seeing exactly how it applies. P-value equals the probability, if the null is true, of obtaining the data observed, or a data set more extreme. Which is stupid here because you can't get more extreme than that. Even if it was the most rabidly sexist boss in the world who said, I'm only ever going to promote women and I'm never ever ever going to promote a man ever. Even if the null hypothesis was as badly wrong as that, you couldn't do worse than this. So more extreme doesn't exist.
Robin, do you mind just taking your keys off?
Oh, are they clinking around? More extreme does not exist.
In this instance.
I'm sorry?
In this instance.
In this incident, sometimes it does. We'll see exactly. Yes, sir.
Just say again what K and X are.
K from the help page on R.
Yeah.
There's quite a lot to hold in your head, and I get confused. So I have to refer back to the documentation or the Wikipedia page, depending on which way I'm doing it, again and again and again. Which one were you asking? M, the number of white balls in the urn, which was the number of females. N was the number of black balls, which was males, which was 3. K is the number of balls drawn. Drawing means drawn for promotion in this case.
X is up.
X is the observation, basically, which is 3 because 3 of the women got promoted out of your sample of 3. It was a 3 out of 3. So they're sitting there, all being promoted. Not all the female staff got promoted. Somebody got left.
I should be feeling a bit lonesome.
Maybe I should got them to keep her company. So we can see that the p-value for this observation, or for this test, is, oh, I've rubbed it off now, 11%. Not significant. Because it exceeds the 5% cutoff. All right?